So here is the neuromuscular junction. And a neuromuscular junction is, just look at the word, neuron, muscle to muscle, junction, where they come together, okay? So neurons, and we're talking about motor neurons, so motor neurons, because those are what innervate skeletal muscle, they come from the spinal cord. So they come from the spinal cord over to the muscle. And one neuron will innervate a group of muscle fibers. Because one neuron, if you remember looking at neurons, they have several axon terminals. So each axon terminal will meet up with one muscle fiber. As you can see that here. So over here in this picture, we're showing one neuromuscular junction. Okay, so this thing here is the axon of the neuron that's coming out of the spinal cord. This right here is the axon terminal. So this thing right here is the muscle fiber. Okay? So if you notice, this axon with its terminal comes over here to meet with the muscle fiber, but it does not touch it. Okay, there's a space between the axon terminal and the muscle fiber. That's called the cleft, or synaptic cleft. Okay, and again, that's just a space there. You can see in this axon terminal, these are vesicles. Here's one. All these things are vesicles. Because remember, a neuron's just a cell too, right? So it has cellular things. So these are vesicles here in the terminal. And they've got these little red balls in them. They are full of a chemical. And the chemical is called acetylcholine. Acetylcholine, or ACH. Acetylcholine is a neurotransmitter. So it's a chemical that transmits neurological impulses or communication. Okay. On this axon, there are little channels. Okay, so there are channels along the axon terminal. So we'll put one here. Oh, God, I hate this thing sometimes. So we'll put one here, and we'll put one here. These channels are called voltage gated channels. And they're specific to calcium. So voltage gated just means that they're voltage stimulated. So they're closed. These are gated channels, so they're closed normally. But if they feel a change in voltage in the membrane where they're sitting, then they open. Okay, so these are going to open from an electrical stimulus, and when they open, calcium is going to move through them. On the other side here, on the muscle cell, the area from here to here, okay, this whole thing, this right here, of course, is the sarcolemma. And the sarcolemma is the whole thing, right? But in this area from here to here where the axon terminal is, where it meets it there, this is called the motor end plate. And it's important because this is where it's going to receive the signal for contraction. So on this membrane, there's going to be also some gated channels. So we'll make them look like this. And they're all along this motor end plate. And these channels are chemically gated channels. So they're gated, they're always closed, but they're chemically gated. So this means that some kind of chemical is going to bind to some kind of receptor on that channel, and it's going to make the gate open. Okay? If you're thinking ahead, remember we have a chemical up here called acetylcholine. Acetylcholine is going to bind onto these chemically gated channels, and they's going to open. Okay? You see here on each side of the motor end plate, we've got the rest of the sarcolemma, and in it, you can see our T-tubules. So that means there's going to be terminal cisternae on each side of them, right? Okay, so down here where the T-tubule comes in, you've got the terminal cisternae on each side, and then down here you also see sarcomeres. These are the sarcomeres, the actin and myosin of the muscle fiber. This is a myofibril right here. Okay, just one of them. There are a ton of them in there, right? So we have to find a way to stimulate the muscle, the whole muscle, not just this one part of it, right, where the neuromuscular junction is, but the entire thing to get it to shorten and contract. All right, so we will talk about that when we get back, or on the next video, sorry.